Welcome to the Insightful Professor. Today we're going to discuss how to write methods in the Java programming language. Java is an object-oriented programming language, and as such, we define and use objects to represent concepts or entities that exist within the real world. And these entities have certain properties that are of interest to us. Some of the properties are data bearing. So what we'll define within a class would be some kind of variable to hold values for that data. For example, if we were defining a class that represented something like a student or a person, then what we would do is define attributes or variables to hold the name of the student, the date of birth of the student, and various other pieces of property that kind of characterize or describe that individual. In addition, we recognize that students, people, whatever objects we're representing, interact with other objects. This interaction is done by performing some kind of action. This is where methods come into play. So methods are effectively blocks of code that will define associated with a class and then invoked as we wish to communicate with the objects of that class. So methods are typically the idea of being some kind of a function or in general a subroutine. And they are invoked as needed to send messages to the object and cause the object to respond in some way. So that's kind of technical, but that's the notion of what methods are about. So when we talk about an object-oriented programming language and we write a program in this language, we're going to create various types of objects. The objects come from classes. The class tells the system how to create or instantiate the object. But then these objects interact with one another, and that's where the methods come into play. So as an example, we mentioned that an object is going to be the instance of something more general. That's what the class is. And we might have a class such as person. Mo would be an instance of a person. Larry would be an instance of a person. Curly would be an instance of a person. They would each be objects derived from this person class. The actions that any person can perform, such as maybe showing their name, or changing their address, things of that sort, would be available to every person. So Mo could perform those operations. Larry could perform those operations. Curly could perform those operations. But those operations or actions are defined through methods. The objects that we create from a class provide a context for which a method is invoked. What this means is when we create an object, technically what we're doing is not creating a variable that holds the object, but what we're creating is a reference variable, a variable that refers to or references or basically kind of points to where the object resides in memory. We then use that object reference variable to qualify calls to the methods. So for example, if we created an object from person and that object represented Mo, then we would use the reference variable for that object to invoke methods whenever it was necessary for Mo to perform an action. Similarly, we would have a reference variable for Larry, for Curly, and any other person we might have created from that person class, and we would use the reference variable that effectively pertained to that individual to qualify calls or invoke the appropriate methods. That's what I mean by establishing the context. So here's an example from something a little bit different than working with the person objects. Let's suppose we have a keyboard and we have an input file. Both of these are defined within our application as scanner objects. So we say keyboard is of type scanner, it's derived from this class. Input file is of type scanner, derived from the scanner class. We invoke the constructor over here by using the new operator, and then we say system in. Well, that refers to the keyboard, the physical keyboard device on the computer, and file would be the name of some operating system file that somehow we previously identified and are making that name now available to the application. We take that file name, create a scanner object, and we refer to that by using the input file reference variable. Now, what does this give us? If you look further down, we're now using input file, then the dot operator, and we're qualifying a call to next line. Likewise, keyboard, and we're qualifying a call to next line. What is next line? Next line is a method that is defined within the scanner class and hence becomes available to any object instantiated from that class. So keyboard refers to an object of the scanner class, input file refers to an object of the scanner class, and we use those reference variables to qualify the calls to next line. So we're doing stream input from the input file here, and then we're doing stream input from whatever the user types in at the keyboard. So we're performing essentially the same operation, but we're operating on different streams of input as designated by the scanner objects for which we're making the call or qualifying the call to the method. So why do we write methods in the first place? Well, we write them so that we can define a piece of code or set of instructions to be performed, and when necessary, we can then perform that set of instructions by simply invoking the method. So we don't have to repeat or duplicate the code. There's a concept here of code reuse. We define the code once, which may consist of several instructions, and we invoke that set of instructions whenever we need to by calling the method. So we don't have to duplicate the code within the application. It's kind of the idea of solving a large problem by dividing it into smaller pieces, and the idea of whatever operations we wish to perform repeatedly, we define them once, and then we do that again and again as necessary. So that's kind of a variation of the divide and conquer principle. But an additional benefit, if you take a look at how classes are defined and utilized, is methods provide controlled access to the data. More on that when we talk about classes. So some terminology associated with the use of methods. A method can be thought of as a sequence of steps or operations that have been defined together and then given a name. We then use that name to say, hey, I want to do those instructions, or I want to execute that sequence of instructions. This is referred to as calling the method or invoking the method. To indicate the method call in Java, the name is specified, and what we then do is we pass to it arguments that are going to be operated upon within the method. So if we have arguments such as the string of hello world, and we want to display them, say on the console, we could invoke the printline method, system.out.println, and then pass to that method an argument, which in this case is a character string that says hello world. If we wanted to print something different or display a different sequence of characters on the screen, we would change the argument that's passed. But we're reusing that piece of code and having it do effectively the same thing, but it operates on something different. That something different is determined by the arguments that were passed or communicated to the method during the calling or invocation of the method. For this method call or invocation process to work, the method being invoked, in our example, the printline method, has to know what information to display. The information that is to be acted upon, or in this case displayed at the console, is communicated to the method by passing that data, that information, as an argument to the method. So the way the method call process operates is the method is going to be called or invoked. The method takes whatever data has been supplied to it or communicated to it through the arguments made in the call statement. The method does its thing, whatever it's supposed to do, and then the method terminates its processing. It's completed its assigned task, so it returns control to the calling routine at the point at which the call was made. This typically is going to be the next instruction following the call. But if the call were somehow embedded within another statement, then it would return to complete the execution of that statement. So the operation of going back or returning control from the called program or the subroutine to the calling routine or the calling program is called returning from the method. There are some important principles to consider when designing methods. Methods should in general be easy to use. We've got to consider the idea that when you write a class and write the methods, another individual may be using that class and using the methods. So the methods should be designed in such a way so this other individual who will be invoking the methods through their code has no difficulty in using that code. So methods provide a way of hiding lower level implementation details so that the other individuals who would be using the methods to accomplish some task are not burdened by those implementation details. So this concept is referred to as kind of hiding that data or hiding that information from the user and providing effectively a black box. So we might refer to this as information hiding. A programmer using a class method doesn't have to know the details of how that method does whatever it's supposed to do. Just simply can look at it as a black box, that this is going to do such and such for me. I don't need to know how that's actually accomplished. This is a notion of what we call abstraction. The idea is we present the black box without providing the implementation details of how the task is actually completed by that method. That makes it very easy for someone to use the method and to use the code that someone else has written, and provides a very useful tool to these folks. So the idea is method design should separate what the method does, what the code does, from how it does it. We don't need to know how the task is accomplished. We simply need to know that this is going to display something on the console. We don't need to know how that's accomplished. So a primary goal then in using classes is to kind of manage the complexity or reduce the complexity of whatever that task is. So we simplify it for those people using the code that we write. It doesn't eliminate the difficulty or the challenge of us writing the code, but it simplifies the use of that code for others. So now that we've provided some background on how methods could be used, why we would use them, let's get down to how we actually declare them. So in Java, a method is considered to be a subroutine, a block of code that is separate from the main stream of code. It is given a name, and then we call or invoke that subroutine at whatever point it's necessary to accomplish the task or the set of instructions contained within that subroutine. So that means that that subroutine must be given a name. That's one of the critical points that we have to consider. Then we have to provide sufficient information to make it possible then to call that subroutine. So as part of the declaration, we not only have to say what the name is, but we have to recognize, is that subroutine going to communicate data back to us? Or will it simply do whatever it's supposed to do and not send anything back to us? But then also, do we need to communicate some information to it? We talked about the term arguments for passing some information or data into the method for it to operate on. So we have to understand what kind of information the method would expect if subsequently we're going to invoke that method. So part of the definition of the method would be this thing that we refer to as a header, where we talk about these modifiers, but we'll also talk about the return type. What, if anything, will be communicated back to the calling routine when the method completes its execution? What is the name of the routine? And what, if anything, must be passed into or communicated to the method when it is called or it is invoked? That constitutes what we call the header of the method. That's going to be sufficient information for someone to use the method. The other part of the method we call the body of the method, and this provides the set of instructions or operations to be performed when the method is actually invoked or called. Users of the method don't need to see that body. that effectively is hidden from it. That's where that kind of information hiding comes from, and what effectively makes this a black box. We simply know how to invoke it, what to get back from it, and so forth, but we don't need to know how it does whatever it's supposed to do. So let's look at this in a bit more detail. The statements, as indicated in the syntax diagram, comprise what we call, again, the body of the subroutine. These will be able to operate on the arguments that have been passed to the method, and perhaps operate on other things, and then produce a result to be returned, provided the method is supposed to return something. If the method is not supposed to return something, but just do its task of operating on some data, then this method will have a return type that's designated as void to indicate don't expect anything back from us. Once we're done, we're just returning control to you, and we're stopping. We're not sending any data back to you. That's what a void method would be. However, if we're going to return something such as an integer value or a double value, then the return type would say int, or the return type would say double, or whatever data type is appropriate for the type of value communicated back from the subroutine to the calling routine. The parameters that are going to be passed, if there are any, constitute the signature of the subroutine, and this gives insight to anyone who's going to be invoking the subroutine as to how to correctly formulate the call. The other part, which we skipped over a moment ago, were some kind of specifiers. These are what are referred to as visibility modifiers or access specifiers. They indicate whether or not we have access to the method from outside of the class. If we cannot see it, if we don't know it exists, we can't call it. So for us to be able to see it, it has to be visible to us. For us to be able to see it, it's designated as being public. If it is hidden from us and used only internally, kind of privately used, we don't even know it exists, then it has an access specifier or visibility modifier of private. From the code outside of our application, we cannot touch it. We don't even know it exists. But if it's public, then we have the awareness of that signature, hence we know how to invoke it, plus we are authorized to invoke it. Value methods and void methods. The value methods are more formally called value returning methods. They will have a return type, something other than the word void, indicating the type of value to be returned when the method completes its execution. If the method is not to communicate or convey any data or information back to the caller, we use the void keyword, hence this kind of a method would be called a void method. Both types of methods, whether it's value returning or void, will have to have a heading and a body. The body is where the action is performed, defines the set of operations, and the heading provides the signature and tells us how to call or invoke the method. Okay, so we've seen value and void methods in earlier programs that we've examined. Here's an example of a void method that simply performs some task but doesn't communicate any value back to the invoker. System out, and then we invoke printline. Printline is passed an argument, in this case the string hi, and it takes that value, submits it to the console, in this case for display, and then it terminates execution, but doesn't communicate any value back to us. So this is not a value returning method, it's a void method. On the other hand, if we had a value returning method, we would invoke it appropriately, again using a reference variable and then the method, and the result of that method, once it completed execution, would be to communicate a value back to us. So the value that is communicated back from the call to next int would then be assigned to the number variable indicated in the statement, because this is not simply a call to the method, but this entire statement includes the call to the method, plus taking the value returned and assigning it to this variable called number. So you can see the syntax for invoking the method depends upon whether it is a void method or a value returning method. A void method, we simply make the call and pass any arguments if the method has arguments. The value returning method, we make the call, but then we have to consume that value in some way. So we receive it, and in this example, complete the execution of the assignment statement. So in the method declaration, we see that there will be a header and a body. The body is typically a compound statement, many operations to be performed, so we include the individual statements that comprise that compound statement within the curly braces. The header tells us, again, visibility, in this case public. It also says static in this example. We have another video on that, and I would encourage you to take a look at static methods. I'll just suffice it to say at the moment that that's something else that we may include typically within an application, and certain special classes may have this. But we're going to kind of dodge the topic for the moment. And then void indicates in this particular example that we're not communicating anything back, we're just doing whatever the body says to do. Display message would be the name of the method, and this particular method has no arguments. Nothing is going to be passed in when we call it. So it turns out that we still have to satisfy a syntax requirement of putting the parentheses. Even though we're not defining anything to be communicated to the method still syntactically has to have parentheses in the header, and we'll also see that it has to have parentheses when we invoke the method. Okay, and here's a quick summary, and I'll let you take a closer look at that. We've kind of gone through that already. So here's an example. We have a method called sayHello, which doesn't expect any input, doesn't return anything. It's public, so we are made aware of it, we can see it, we can call it or invoke it. What it will do is simply print the message hello, or send that string hello to the console for display purposes. So how do we make a call to the method? Well, because it's void, there's nothing coming back, so we don't have to say receive or consume any value. When we use the name of the method, and because it has no parameters, we don't pass any arguments to it. So here's a simple call illustrated down here. Say hello, but the parentheses are required, and then of course the semicolon to conclude the Java statement. So this code is available in a file called simplevoid.java, and we'll go take a quick look at that right now. Here's the code for simplevoid.java. Feel free to grab the file and read the comments. I'm going to give you an explanation of the behavior of this code right now. So we have a class called simplevoid. This is an application. It has a method in it. The method is called main. Every Java application has a main method. This is where the action begins. Now, within this method, we're going to make a call to the method called sayHello that we're defining. So we simply put out a message by making a call to the printline method to say we're about to call that routine. Then we're making another call that says this displays just before we make the call. We put out another message that says this displays when we return from the call. And here is the actual call to the method. This is a case where we're going to be transferring control. We're doing sequential execution where we'll execute this statement, this next statement. So here we kind of suspend execution of the sequential flow of instructions and jump out of this sequence to go to wherever sayHello is, execute that, come back, and then resume our sequential execution. So let's look at where sayHello is defined. If we scroll down further, we see the actual definition of the sayHello method. So what we have here is, again, public, static, void, not returning anything, say hello being the method name, and the parentheses indicating nothing is going to be passed in when a call is made. And then it simply makes the call to say hello. So we can compile the code and we can proceed to run it to examine what actually happens when we go through this process. So the output says, okay, calling say hello. Remember, that was a message that was displayed up here on line 34. Then line 35 displays the second message to say I'm about to actually make the call. And then line 36, we go into say hello. And what happens is the hello message is displayed. That's where the control has been transferred down to line 57 effectively. That's the statement that actually produces the hello message. Then control goes back to the statement that follows the call to say hello. That's the basic idea of declaring a method and then invoking the method from within an application. So the code is available in a file called simplevoid.java, and I encourage you to take a look at that. Now, having seen a simple example of how a method is declared and invoked, let's turn it up a notch and look at how we actually communicate with a method by passing information or data into that method so that it has something to operate upon. We say that values that are sent into a method are referred to as arguments, so that when we make the call, the data that we provide to the method, we call that an argument. So hello as a character string in a call to print line was an argument. str as some kind of a variable is being passed into this parseInt method. So that's how we communicate data in. Somewhere within the header, we have to be able to ascertain what the values are or what kinds of things have to be passed in. This is what we refer to as a parameter, and the thing that we actually pass in is referred to as an argument. So kind of a subtle difference, but it's an important distinction. Sometimes we refer to it a little bit differently. We may refer to the definition of the parameter as what we call a formal parameter. That announces what the expectations are of the method. And what we have referred to as an argument is called an actual parameter. That is the actual thing that's being passed in and will map to the formal parameter. So we can use the terms of arguments and parameters, or we can make a distinction using the single term of parameter between a formal parameter, kind of the expectation of the method, and an actual parameter, what is actually provided or communicated when a call or invocation of the method occurs within a program. When a method is called, the value of the argument or the actual parameter is assigned to the formal parameter. It is effectively like an assignment statement. Its value is copied into the formal parameter. The formal parameter is effectively a local identifier. It's defined within the method, and its scope for that identifier would be the bounds of the method. So here we're calling display value. So here's 5. That would be the argument or the actual parameter that's passed to the display value method. The display value method is expecting an integer. Clearly 5 fits the bill. 5 is an integer. It maps nicely. That's another point when we make a call, is the data types have to be compatible. I obviously could not pass a Boolean or a string or some other data type that was not numeric into this. In fact, I couldn't even pass a double, which is numeric, because this is expecting something from the integer family. They have to be in agreement. Otherwise, the call fails. I'll get an error. Once num has been received, I can utilize it within the statements that constitute the body of the method. Here, I'm simply taking whatever that value is and displaying it to the console. But how did num get the value? What we can think of as happening here is that num gets assigned whatever was passed here as an argument. It's kind of like there's an assignment statement that occurs during the call. Num is assigned 5. Then when I refer to num, I have that value of 5 and I can operate on it. So here's an example from a program called simpleparameter.java, where we have say hello, but say hello is a little bit more exciting than it was before because now we're passing something into it. We're passing a string and a reference variable to some string object. So we get that string reference, and then we say, let's print out hello to the console, followed by let's print out whatever name is pointing to. And that will be a connection to the actual object. So here the object is a literal string of mo, and we're passing that, but technically we're not passing the string, we're passing a reference to the string, following that reference, and obtaining the value of mo. Let's take a look at this guy in action. So here's the call to display message, which communicates the request to say display mo as a string. And we go down further, and here's the method, and it says hello, followed by whatever got passed in as name. Now in this case, we're passing a literal, and we're using this identifier to point to that literal string object. In the second call that we make, a few lines further down from the original call, we're passing a variable called somebody, and that happens to be associated with or pointing to a string object which has the value of curly. So this time when the call is made, name is actually going to take the same value held in somebody, which is the pointer or the reference to curly. So let's go ahead and compile this, and then we'll run it and see what we get. So in the main method, about to call the method, that should be back here just a ways. And here on line 7 is where that message is being sent to the console. And we see it displayed right here prior to making the call on line 11, which passes a reference to mo. And sure enough, mo is what got displayed. Then we pass a reference to somebody, which is to the string of a value of curly on line 15, and we see that call completes by displaying hello curly, and then finally this second message in line 16. That's the basic idea of how it operates. So again, the code is available in a file called simpleparameter.java, and I encourage you to take a look at that code and give it a try. Now we've used the term formal parameter and actual parameter already. Here we present that a little bit more formally. There's another variation on the program we just demonstrated, which has a slightly different twist to it, and that's in a file called simpleparameter2.java. And again, take a look at that and see if you can ascertain what has changed and get comfortable with that. Now, an important point about these identifiers that come into play is they have lifespans. So when we pass an argument to a method, the argument's value is copied into or assigned to a parameter. And the parameter is a local identifier, local to the method. We actually can think of it as being a local variable. It comes into existence when the method is activated. It gets populated or assigned an initial value through the call by copying the value of the argument that was passed and assigning it to that local variable, to the parameter variable. And that local variable continues to exist until the call to the method completes. At that time, the variable ceases to exist. So that's the lifespan or the lifetime for that particular variable. The formal parameters result in the creation of what are called automatic local variables. The creation of this local variable is automatic, accomplished by the call within the Java runtime environment, and the termination or the removal of the variable, the disposing of that memory, is also automatic. So it's automatically created and automatically removed from the environment. When the call completes, the storage is freed up. We don't have to do anything to cause this to happen. Simply declaring the parameter causes this to happen when we execute the code. It's all automatic. We've talked about scope in earlier videos, but the point now becomes hopefully very clear. Why does it make sense then that if an identifier is local to a block of code, that I cannot refer to that identifier outside of that local block? We explain that by saying it resides within a local block. That's its scope. That's where valid reference can be made. But now we get a little bit better idea. Because it's effectively an automatic type of local variable, it doesn't even exist prior to that code becoming active. It only exists when that code is active and executing. When that code terminates, it again ceases to exist. So therefore, scope is associated with a concept of storage being dynamically allocated and dynamically deallocated at runtime. When we write our methods, if it's a void method, we can simply terminate the code after our last executed instruction. But if it's a value returning method, we have to do one more thing. We have to communicate back to the caller the value that we want to return. We accomplish this by using what's called a return statement. When we write the code for the header of a method, we announce what kind of value will be returned. The return statement will say return, and that includes some kind of an expression which must identify a value of the promised type. So if we said we were going to return double, the expression that follows the return has to produce a double, or something compatible with a double. It could be an integer that gets converted to a double on its way out of the method, but it has to be of a compatible data type. If a return statement is not present within a value returning method, the code won't compile successfully. This is a requirement. Now, a return statement without an expression or value could be included in a void method. Some people like to do this just for completeness. We know that we're not going to execute any more instructions because there are no more instructions after the last one. But just to be clean and kind of complete, some people will code a return statement to say, at this point, I am exiting the method and returning control to the calling routine. That's not a requirement in a void method, but you can include a return statement. Just don't pass anything back. Now, the return is kind of absolute. Once a return is executed, if sequentially there are any statements that follow the return statement, that code is said to be unreachable. They cannot be executed because the return is an absolute exit of the program. So if we were to include in our program an assignment statement, another assignment statement, a return statement, and follow that with yet another assignment statement, and all of that code was in the body of a method, it wouldn't make any sense. This last assignment statement could never be executed. The code is unreachable. And the compiler will quite nicely bring that to your attention. It says it doesn't like that. The code cannot be reached. So keep in mind the behavior of the return statement. And I think that is probably a satisfactory introduction to get you started with writing methods. Given you quite a bit to think about there, and we encourage you to download the code, try it out yourself. And if you found the video useful, consider giving us a thumbs up. And furthermore, consider subscribing to the channel to be notified of future postings. And once again, thanks for watching.